There we go, it's recording. So welcome everyone to our second Backyard Invention Series talk. And it's my pleasure to welcome Ben HalfPenny. He's the Senior Instrument and Control Engineer, and he'll be detailing his online water metering system, as well as SBCs for intelligent remote presence. So I won't steal Ben's thunder in going through what the talk's going to be about, but Ben's got a really experienced history in engineering, including working in the Middle East, Southeast Asia, over 16 years building power plants, desalination plants, and also working on electrical grid management systems. So recently, Ben's moved to Townsville and is enjoying sabbatical hiking and rock climbing. I love that. So thanks, Ben. I'll hand it over to you now.
No problem. Thanks for that, Mel. Thanks everyone for logging in. I think I actually may have climbed on the background that Mohan's actually got on at the moment. Okay, so the format of tonight, it's actually going to be a sort of a two-part presentation. The initial part will be on the actual water monitoring system itself. We'll have a short question time on that, and then I'd just sort of like to go into single board computers themselves and how they're really a fantastic addition to any engineers. I'm not talking just electrical engineers, it could be civil, mechanical, aero, you name it. They're a fantastic piece of equipment, and I'm going to do some evangelizing tonight. Okay, so on the water metering system that I've installed, essentially the rationale was we've got a block of units down in New South Wales, and at the moment it's just a single water meter which feeds all 4 units, which means there's only a single bill which is paid by us, and any water is paid for in each week's rent, which works perfectly well as long as you don't have one person that is using 90% of the water or spending all day in the shower as one person did. So what actually happened was we had a new tenant move in, and that person started calling up, and I think it may have been halfway through their first week, and said there's something wrong with the hot water system. It keeps running out after only a few minutes. So you'd send the plumber around, the plumber says there's no problem. So you send the electrician around, the electrician says there's no problem. And this got repeated about 3 times until a few other issues came up and he did move out. Subsequently, we've actually learned that what was probably happening was he may have had an ice addiction, and apparently it makes your skin itch, and a good way of relieving that is to sit in the shower all day. It all makes sense in hindsight. In any case, after this episode, we decided we've got 2 options here. We need to know what each unit is using. We can either ask the council to install individual water meters for each unit, or we can look at installing private meters. Now, the public installation, as soon as I looked up the price list with the council, I started looking at $527 just for meters, and then they have a price list of every other little itemized action that would have to be performed in order to install these meters. And it was going to cost a fortune. On top of that, every meter costs a considerable amount to actually service every year. So whether it be electricity, whether it be water or data, a lot of what you pay for that service anywhere in Australia, it's all that flagged for. As soon as you have that meter, you're paying a lot of money straight out the door. So in the end, we elected to go the private route. So we came up with a few design considerations. It obviously must meet all Australian standards. If you're going to provide any bill to tenants, it would be very unfortunate if they challenged you in court and then it was obvious that you've got a $2 meter on there that doesn't comply with any Australian standards, and even worse, possibly poisoned them because you put the wrong material into a potable water system. So there was a significant amount of research what metrology standards and material standards were required. The system also had to be highly reliable. So as Mel said, we've spent a lot of time overseas, and when originally we were designing this, we were in Brunei at the time, and we'd at most come back once a year. So the system, if it went down in February, may not get fixed again until December if it wasn't sufficiently reliable. It had to be privately powered. Obviously, a tenant wouldn't be happy if we parasited the electrical requirements off one of their units. There was also an additional reason this: we were actually using the 40 units power supply to provide all the security lighting outside. So this also provided another route for us to normalise all that and take it off their supply. Must not rely on any vendor-specific sort of source or bespoke protocols. So a lot of the equipment out there, they all advertise that any connections will go back essentially to their cloud server, and then you can access it from there. The problem is that you could run into a position where if that cloud service disappears, you're left with no service. So we wanted to be in complete control of the whole life cycle. It had to allow significant future extensibility. I guess being all engineers, you probably realise that you make a start on something, you finish it, and then you think of a million different ways which you could extend that. And I knew that was going to happen. It had to allow for properly compensated battery charging for battery life. Anyone who's looked at their own home storage systems has probably noticed that storage is really by far the most expensive part of the whole mix. And I've had poor chargers before essentially destroy batteries in 6 months. So I really did want a charger, and this is a solar charger, that would ensure the batteries lasted for their full design life, which was expected to be about 8 or 9 years minimum. And lastly, it had to be secure, since this system would be collecting information that could be considered personal to the tenants. So based on those design considerations, we came up with a system whereby we had approximately 700 watts of solar generation on the roof, being fed down to, I'm not sure I should actually mention brand names, should I, Melanie? Down to an MPPT solar charger, which charged two 250 amp hour lead acid batteries, or gel lead acid batteries, which is far in excess of what was actually required. Now, importantly for me and my concern on the batteries, you'll notice down here that we have thermal compensation, so that all phases of charge are thermally compensated. The applied currents and voltages for a lead acid battery do vary depending on the temperature of the battery itself. And this is particularly important, especially for the final float voltages, which, given the initial light loadings, we're expecting to be on float most of the time. The MPPT charger also had the benefit of, although it used its own bespoke protocol, it did come with a converter to RS-232, which allowed us to easily connect it up to any computer system. To power all the 240 volt equipment, which was all the common security lights, and the 4G modem, which we needed for online access, we also added a 24 volt to 240 VAC inverter. So over the left, you can see the basic components. It is a little bit rough. As I mentioned, I don't actually get to this location very often, so a lot of it is thrown up very quickly. The 4G modem is there. A lot of the solar equipment is here. That's our MPPT solar charger, our various isolators, and our inverter, and the 232 converter down the bottom. Now, the hardware on the control side, we use our 24 volt bus to wet the contacts on all of the water meters themselves. So the water meters are a standard volumetric meter, essentially exactly the same as what each of you would have at the front of your house. These meters, though, are a little more advanced in that each one of them comes with a tiny little port in which you can insert a reed switch, and every time the smallest wheel moves 1 revolution, it pulls the reed switch in. It's got a little magnet on it. You can just see in the bottom left the reed switch inserted into the meter. So 24 volts was run through those reed switches, and it operated relays which were kept in the main control box, which are down here. The primary purpose for those relays is to provide a little bit of isolation, but also to provide multiplication of the contacts as well. So we couldn't get any redundancy in the reed switch itself. It's only a single contact. They don't make any dual throw switches. So the redundancy came in from these relays. So each one of these relays will be fed to each one of these digital input cards on the right-hand side. So you'll see this R1 in the final system would have an output contact going not only to this unit, but to this unit. So at the moment you'll see the purple, it's not actually connected up like this. I was in a bit of a hurry to get out of there at the time, so this part is not fully redundant at the moment. I just need to run a couple of wires and it's all done. But for the moment, I haven't actually had a problem, thank goodness. So the rest of the equipment requires 5 volts. So we have a pair of 24 volt to 5 volt converters, again for redundancy, so that if one of these fails, we always have the other system still functional. The 5 volts, it powers, I'm not sure whether anyone's used a Raspberry Pi. They're a single board computer, and to that via SPI, I've attached a serial peripheral interconnect, bus standard for reference. I've connected an additional digital input, digital output card, which goes on top. So that provides us with 8 digital inputs and 8 digital outputs. So for our purposes, at this point, I'm only using the initial 4 digital inputs. However, I have all this additional functionality arrayed around here for future expansion. So future modifications, just to make it a little bit more redundant. And what I would have liked to have done was actually added instead of direct power supply from each one of these power supplies, I could have used a diode to supply from each supply to both. So even if one power supply failed, I still would have had both single board computers available. Future modification. Okay, and this is the final result. So as I mentioned, it is a little bit messy. The 2 single board computers are here and here. The relays are in the middle, and the interface to the external systems are right here. I would have liked to have used in-rail mount components, but unfortunately when I went around to the electrical wholesaler, he was asking an extortionate price, so I went around to the auto electricians instead and got something considerably cheaper. So the power supply units themselves, they've been mounted outside the enclosure just for better heat dissipation. It's not a high current load, but I prefer the heat was outside rather than inside. What you also may notice is the Ethernet cable. Now this Ethernet cable, most of the time, doesn't actually fulfill any purpose. Many times in the past, I've had a problem securing systems whereby if you log in remotely and you make a mistake with the firewalling, you've suddenly locked yourself off from the system. So the idea of adding this interconnect is the primary connection comes through is via Wi-Fi, which has a VPN running over it. Now, if I was to lock myself, for instance, out of this machine here via the Wi-Fi VPN route, I always have the ability to come in through the other unit, through the internal cable, and back in and unlock it. There's also an additional USB connection. Now this connection is the connection through to the MPPT control charger. Unfortunately, it's connected, but I haven't actually managed to connect to the controller yet. I believe the signals are coming out, but the controller is not responding appropriately. So either there's an addressing disconnect there, or maybe there's an electrical disconnect. I'm not sure. That'll be for the next time I'm there. I really need to be able to get access to the 232 cable itself to actually see what's going down it. So other than the hardware side, most of the project is probably actually software most of the time that's gone into it. So these particular single board computers, the way you set them up, they just come as a bare piece of hardware, and you complete them with a, in this case, micro SD card. So you'll flash the operating system to the SD card, modify a few files for the base configuration, including the addition of SSH so that you can log in remotely. And when you start it up, the operating system will unpack itself. Once it's all unpacked, you can log in via SSH, which is a secure shell connection. It's essentially a secure form of telnet for anyone that's used that. VPNs were then configured. So to configure the VPN, you need an internet connected server. The software was installed on that server, which is actually located in the States. All of the security keys are then distributed to each of the two Pis, the security server, and obviously my home machine, so I can log into them. And it's essentially creates a network not significantly different to what you have at home. The next steps are to install the development environments. So in this case, it was G++, Make, Vim, and a few other software components which were required to finish the project. And to be able to communicate with the digital input boards, the SPI, the serial peripheral interconnect bus, also needed to be enabled, as since by default, both the SPI and the I2C buses are all locked off. Okay, so for the remote access, we used a 2 gig wireless broadband plan. As I mentioned before, we have the internet addressable machine already on the internet, and the encryption keys for each device. Now, with a 2 gig wireless plan, this is probably the smallest amount of bandwidth I've ever used for this sort of function. And I was a little bit concerned about how much latent bandwidth was actually required just to operate the VPN. So even if the VPN isn't carrying any data, there's a certain amount of transmission which is required to actually maintain its status. In the end, this amounted to not much more than about 70 megabytes per month, however, which was well within reason. In this case, just for reference, OpenVPN was used. It's one of the most common open source VPN programs around at the moment. However, there's many other options out there as well. One that's got particular publicity at the moment is WireGuard. It's published as being one of the only VPN software out there that has actually been fully verified as being secure as much as is possible. And on top of that, by using the VPNs, it means we can set our firewalls up to drop virtually all other traffic which comes in via the internet connection, which makes it highly secure. Okay, if we go back to the software design itself again, the software function was actually reasonably simple. The 4 main functions were to, on startup, initialize the initial state of the software. So it would, well, on startup, read any existing log files. If there's no log files, then it creates it. If there is a log file, then it will read existing totalizer data and add that to the totalized value in the RAM. Once it's started up, it runs through each of the 4 inputs on a progressive basis. So in this case, I believe it's once every 480 milliseconds. It will do a scan of the input. If the input has changed, then it knows there's either been a rising edge or a closing or a falling edge there. So the edge event, any edge event is written to log for diagnostic purposes. If it's a rising edge, then it knows that it needs to add an additional 5 litres to the totalizer in memory. And once it's done that, it will also go out and update all the log files as well. So if, for instance, there was a power outage at any time, the totalized value would not be lost. I've also added a little visual display for it just for diagnostic purposes at this point, and whenever there's a change it also goes through and updates that. The way the ncurses library works, it creates a static display which to modify any value you have to specifically tell it to change. So they were the basic 4 functions. To implement that, we created object classes for overall units. So on initialization of the software, it works out that it has to create a unit, unit 1, unit 2, unit 3, unit 4. And then each unit will have a totalized meter attached to it. So it will create that object as attached to that unit. And then each one of those meter objects will have an input. It's basic object-orientated coding, which is a nice change. Too often these days I use linear coding, which is very much like the old BASIC system. The development was originally in Python, which is the most common language used with the additional add-on boards that I used. However, there seemed to be a problem with the Python environment, and after about 4 or 5 days of operation, I was finding that the whole system was crashing, which was very frustrating because, as I can see Kenny nodding his head, as he may have worked out, in those initial development days, most of the time you're restarting the software at least once a day. So I only actually found this out once 80% of the coding was actually complete. So there was a significant amount of time that was wasted in starting from step 0 again with C, C++. However, it was actually a very interesting exercise to go back and translate it across. So in C, it's mainly standard libraries that were used: CTime to obviously get the time and manipulate times, CStrings for strings, and FStream for file manipulation. The other classes used were wiring PyDev, and there's got to be a big thank you to go out to a British guy who actually wrote that particular class on his own time to control these boards, and the ncurses library as well for the screen display. So just a note on the development environment. As I mentioned, the primary server for the VPN is actually over in the States. So the latency between Australia, the States, and back to New South Wales ended up being about half a second, which became very frustrating for development. So in the end, most of the work was done locally, and only the compiles were done on the Pis down in New South Wales. Okay, so the end result of that, what I've done with this chart is I've just taken about the last 2 months and normalized all the meters to 0. So now we've got an accurate representation of the usage on each unit for 3 of them. Subsequent to the last time that I actually worked on the hardware, I did find out that unfortunately the furthest meter, I suspect the voltage drop in the loop back to the relay and out through the water meter is a little bit too far. So the relay isn't pulling in reliably. Looking at this, I suspect it's probably only pulling in about 50% of the times it should. So the next time I'm down there, I do have a number of spare cores. I'm just going to have to double those up, which should be easy enough to do. Now, apart from the obvious utility of knowing what each unit is using, I did actually discover a side benefit of installing your own meters. Now, when I originally looked at the cost of the council meters, I did notice a strange little note on there, which essentially indicated that a lot of the meters are recycled, old meters, and I suspect potentially not as accurate as they were when they came out of the factory. When I compared the public meter with the combined value of all of the private meters over a single quarter, you'll notice that we've got approximately a 32% difference in that the public meter is charging me for considerably more water than what appears to be actually used. So the next time I'm back, I'm also going to have to be checking to make sure that there's no additional taps there. Otherwise, I'm going to have to go in and have a chat to council for a calibration of those meters again. Okay, so as I mentioned, probably from the first day, I was working on a to-do list for things that I hadn't thought of before, but which I really do want to do in the future. So now that I've got access to water totalizer values, it adds the ability to provide water leak alarms. Now, I'm not sure whether anyone in this presentation has had it happen before, but certainly at the units we've had pipes burst there, and sometimes it doesn't get reported for maybe 12 hours, maybe a full 24 hours. We had friends in Townsville go away for a weekend. A pipe burst probably the first night they were away, and they only found it when they got back at the end of the weekend. The water was pouring down the street, and obviously they were responsible for the full charges on those meters. So I consider a water leak alarm to be quite valuable for anyone, whether it's a private residence or units in this case. The configuration at this point is all hard-coded, so any modifications which I have to the arrangements all have to be changed in the code itself, which means it has to be recompiled, re-uploaded, and restarted. Ideally, I'd use a simple text configuration file so that you can just restart the software. Automatic printing of bills, that would actually make it easier for the agent. At the moment, however, the agent is going around the properties and manually taking the values. And in that respect, I've actually found that quite valuable, because now I know that someone is actually regularly going around to the property and checking to see if there's any issues around there. So I may actually put this function on the back burner. As I mentioned before, each meter, whether it be water, electrical, data, it's all that flagfall that costs money. So at the moment, we do have 4 electrical meters for this single block. What I would like to do in the future is to change over to all smart meters, which are built internally as well, and then just have a single meter coming from the public provider. For a block of 4 units, there's not a significant saving there. However, I know particularly for larger blocks, there's a number of companies going around now trying to entice blocks into changing their systems in this respect, because the savings can be quite significant when you've got 20 units or 40 units. I need to wire in a few of the relays into the security light system. At the moment, the security lights come on throughout the day, which means that the batteries are being drained when they don't really need to be. At the moment, the log files are all plain text, so they really need to be anonymized for privacy reasons. The addition of security and fire detection systems. So for instance, when you're a remote owner, it's not uncommon that you only find out about something 6 months past the date that it actually happened. So if you do have your own window into what's going on, whether it be fire alarms which keep going off, it allows you to proactively address some of these problems. We have found that some tenants, I think they're concerned and possibly put off by a lot of agents that if they complain, then the rent's going to go up or they're going to be considered troublemakers. We take a slightly different stance in that we'd like to know as soon as possible. And also the addition of a common internet service through the same IT systems. So are there any questions?
Thanks very much, Ben. I think that's quite ingenious, actually. I could just imagine almost any agent looking after a block of units could make use of something like that. I hadn't considered that as an issue before.
Well, it's mainly an issue for the owner. The problem is agents, usually the people who are managing rental accommodations, often it's only a stepping stone into actually selling property, which is where the actual money is. So they're there for a very short time and they're not as interested as they should be.
Makes sense to me. I'll kick off with a question while you guys are thinking about them. I had two questions, Ben. One was, you know how you mentioned you hardwired in an Ethernet link just in case the Wi-Fi didn't work or a firewall issue locked you out. Did you actually encounter that when you were doing your original design?
Well, it's Murphy's Law. If you have it, you don't encounter it.
True, true.
But the reason it's in there is that I have encountered that problem a number of times in previous work. When I was in Brunei, we had one temporary system, which was actually 120 kilometres away from home. And I did have to drive out there twice because I managed to lock myself out.
A brilliant risk mitigating factor there, and you'll use it one day, no doubt. And
well, it is actually handy for communication between the two Pis as well. If you do need to transfer files, it's a little bit easier just to go through the hardwired link than to go through the VPN.
Very true. The other question I had was, I really liked your idea of on your to-do list about having the possibility of being flagged if you have a water leak. And I just thought so many other people could use that even without being in the unit complex. And I haven't seen that in even the new IoT style water meters they're proposing with the government. Have you considered putting forward that idea to other people?
No, I haven't been. It's a problem I've seen so many times. As I mentioned, friends only a few months ago had this problem. They go away for the weekend, the water pipe breaks, and the neighbour was a plumber, and they must have seen the water pouring down the street, but the water stayed on. Whereas if you had this system connected up, it's not a hard step to say, if water use goes above X amount in maybe over a 1 hour period, then email this address. So at the moment, it's quite easy to set up an email from any computer system. At the moment, each of those Pis, I do actually have them configured so that each day they send me a basic report to say that they're healthy, their storage is fine, processing limits below about 20%, just to say that everything's healthy. And it's only a small step to add that functionality to say, well, look, proactively, something's wrong here.
It's a brilliant idea.
Yeah, I'll just say something, Ben. I haven't got a question, but I can certainly relate to what both you and Mel just said before, because last year we had a connector for our water pipe just on the side of the house. That connector there doesn't cost very much, but it actually burst. It was underground. We spent quite a while looking for it, but I guess that the plumbers would have been able to find it much faster, but being novices, it took us a while. But that was, I don't know how long that was leaking. The water was just coming out for, but this is just every day at night time, and we didn't know that the water was just getting wasted like that. And I saw a lot of water at the back of the house, and saying, oh, something's just not right here, but we would have lost a fair bit of water without even noticing it. So that system would have been just fantastic.
Yeah, well, that sort of fault can be found quite easily with this. At the moment, the graph that you can see in front of you, that's just the totals for the day. But there's absolutely nothing stopping you from changing the chart so you can see the minute-by-minute usage. So a small leak like that, you would see that as a progressive, constant rise over the course of the day. You'd see people turning on taps, but then it goes back to rising at the same rate again.
Ben,
So Kenny, how much would you pay for this? I might have just found a sideline.
Yeah, well, like if I know roughly like how much it costs, like if it would save us hassles and everything like that, that would be very nice, because just knowing that information would have been, just having that information would have been just great. Because at nighttime we're not using anything. There's no water actually coming through, but yet the water is actually just getting wasted. Yeah, exactly.
Yeah. Well, even worse, you can cause structural damage as well if it's in the wrong place, if it's under foundations, or if you want. I think he'd be able to see my email, wouldn't he, Mel?
No, your email is not here.
Okay.
I was specifically going to ask you.
I'm going to write my email at the end, and if anyone would like any tips on where to get water meters or that sort of thing, send me an email. I can. Well, actually, a lot of the software you can probably actually use just as a starting point. Anyway, I'll put my email at the end so you can contact me. Sorry, Mohan, I think you were going to say something.
Oh yeah, so I was just going to say that I really like the idea of the sending an email when there is a water leakage or something. Few times what has happened to me is I go and turn the water on for my swimming pool, and mostly I do in the evening, and I completely forgot that only the next day morning. And I wake up, I see that, so it happened a couple of times, like generally what I do is, I just come and turn the timer on my kitchen oven, but sometimes I don't listen to that too. So it happened to me a few times there. But I was going to ask you another thing, like how much your total system cost?
If we go back, the solar's are obviously different. So for the sort of thing you want to do, you wouldn't have to worry about the solar. The solar by far was the most expensive component of the system. But for instance, if I can just change to the laser pointer. So these are Raspberry Pi 3s. I believe they're probably around $30 or $40 now. If you want, you can go and get a Raspberry Pi 4, which will handle 2 4K monitors for about $100. The single board computers themselves aren't expensive. The meters themselves, I think if I can find my notes, I can't see it here, but from memory, each meter, including the read switch and shipping, cost approximately $135. So I think if you had one water leak, you'd pay for the system quite easily.
Oh yeah.
I said probably the most expensive part of the whole hardware installation on the control side was actually going to be the DIN mount terminal strip if I'd purchased that. The wholesaler, I think he wanted to charge me close to $160 for the number of terminals that I needed just for this short area here. It was absolutely crazy.
Are there any other questions for Ben?
Just a comment. Ben. Thanks for that. Can you hear me?
Yeah, I can.
Yeah. Okay. The one of the water leaks that you get in a house is the toilets, and that's a continuous slow leak. And to detect that amongst your other use, you have to have a pretty good history for that household or that unit, or else some fancy analysis of the data to show that the things leaking all through the night, for example, would be a way of detecting it. I'm just sort of, I've got a bit of a leak right now in one of my toilets, so I'm thinking, this is why I'm thinking about this.
You would run a fast Fourier transform on it, Mel. You would?
Yeah.
DC offset.
Yeah, something like that. Yeah. And the other comment I want to make is that the Townsville City Council are in the process of encouraging people to use to have their smart meters installed. And they actually came out with an offer of some free installations. And I put my hand up for one of those. It's just been installed, and I haven't even looked at it, at what it does. But they say that if there's any unusual usage, they'll send me a text.
Yeah,
So,
it'd be interesting to see what functions they provided for.
Yeah, well, I don't know that. As I say, I don't. They came around and said, "Do you want a smart meter? They're going free," and I said, "Yeah, why not?"
Why not? Yep. We received the same email.
Yeah.
No, I'm not sure whether they did or not. The email that we got indicated that the web interface was there. However, what would be quite useful doing that is they provided an API as well, whereby you could actually download your own water usage as well on a minute-by-minute basis to your own machine and then process it there. It'd just mean that you could provide your own functions if you wanted to. Even if they haven't implemented it on their software platform, you could then implement it on yours.
That's right. Well, as I say, I haven't actually. I'm a bit lazy. I haven't even looked at it yet, but I'll get around to that. I suspect it. Well, I don't see why you shouldn't be able to. They say there's a website that you can go in and look at your account. I guess it depends on how often it's updated.
Yeah. Well, sometimes remote meter reads like this, they may only read it once or twice a day still, just to keep data bandwidth limits down. So the deal they may have with a telco, I'm not sure how they're communicating, but the deal they may have may say that you get 2 slots a day or 4 slots a day to communicate with each meter. So, were there any other questions, or should I get to the evangelical bit?
All right.
Oh, can I just ask a quick questions? Sorry,
Yeah,
Ben.
sure.
Yeah,
No,
I'm very sorry, but I had to just take a phone call, and I missed whether you used an if this then else broker or something like that to communicate with these things.
Sorry, could you say again, Ron?
Oh, okay, so you're saying sending an email and things like that. So does that come from like the if this then that broker that they have for when you do connect to the internet to make your decisions doing this remote controlling? I walked out when you sort of said that you weren't going to use the US server area or something like that.
No, well, you probably could do it like that, but in this case, it'd just probably be a simple bash script.
Yeah, okay, I'm a little bit ignorant in the processes and the nitty-gritties of those. So
it's like the command prompt in Windows, except it is a programming language in itself.
Okay, so you've got it running on your own local machine somewhere.
Correct. The software that actually runs the system is running on each one of those Pis. The software is duplicated. It's actually exactly the same software.
Okay. Yeah. Okay. And so you're directly connecting to that via your VPN, like you said. Yeah. And you're not using the idea of the data brokers for most of the, most of the Internet of Things stuff and the remote sensing and everything like that.
No, it's probably a fault, but I'm probably one of those people that spends 24 hours doing themselves what they could have got someone else to do in half an hour.
Yeah, but you have your independence, so you don't have to go through their server and everything like that. Yeah, that's great. Yeah.
So I know my software, that'll work for the next 16 years if I leave it there easily.
Yeah. And the only other thing I thought as well too was that to keep it all within the standards and stuff like that, the meters that you bought, were they sort of like from overseas or did you buy them in a local importer?
No, they're actually purchased from Honeywell.
Oh, excellent. Okay. Yeah. Do they have an industrial food grade one at all that has its own Hall effect sensors or something?
In this case, this is a potable water meter.
Yeah.
It's a volumetric meter. It's not Hall effect or anything like that. So it's, from memory, it's a vane type volumetric meter. So essentially, the water fills up a chamber, and then the vane moves around and lets that water out, and
so you'll
that's,
have a
that's
pulse.
what powers the wheels.
Yeah. Okay.
And those wheels, which you'll see on any of your water meters, they all
Yeah.
work more or less in the same way. The base wheel, or the lowest value wheel, has a simple magnet on it, which passes in front of the reed switch and actually opens the reed switch once each revolution.
Yeah. Okay. Yeah. It's interesting with the reed switches and relays is that they have about a 10 million or 1 million count guarantee on them, and it's just interesting how quickly 1 million counts turn up over a couple of years on the electromechanical type devices, isn't it?
Touch wood, we haven't had an issue so far.
Yeah. I had a clock. I built a clock one time just to do something, and it was operating a relay every 30 seconds.
Yeah.
And it's been running for 15 years now, and it passed its million mark a couple of years ago. So yeah.
I do find that sometimes it's a particular design or a particular batch will have fantastic lifespan, regardless of whether it's a reed switch or a relay or what it is. And then some others, they were just, maybe even they look the same, but the life is nothing like the other type. There's just a tiny little design variation which changes their reliability completely.
Thank you.
Okay, so if we move on to what I wanted to sort of set the stage for was to give an idea to everyone of the capabilities that have really become available, I guess, in the last 10 to 15 years with the development of a lot of these small computers, single board computers. So the side benefit of everyone's mobile phone, or all these people that change their mobile phone every year, is that they're also funding the development of low electrical power, but high power processors. And these processors have allowed us to create essentially miniature computers. These things are as powerful as a full desktop was 10 years ago, or in some cases only 5 years ago. So often with these, you've got the resources to run full operating systems, whether it be Windows or Linux. In a number of cases, Windows is even nice enough, if Windows is your preference, to give you a whole Windows development environment for free to put on these systems. The predominant architecture out there is ARM. You can also get 8.6 variants as well, which is exactly the same as your desktop, although unless you're really getting down to the low level, a lot of the differences are unnoticeable to the user. Something that, particularly for engineers, could be exceptionally useful as well. I think everyone probably in this presentation, probably either at uni or for work, has used MATLAB. Now, particularly for the Raspberry Pis, MATLAB actually provide connectors specifically for the Pis. So you can control an interface with these devices directly from MATLAB. You can change inputs, change outputs, even the indicator LEDs can be controlled. So essentially, you're just given MATLAB a real world interface, which is one thing the software is sort of missing. Often you have the software, but then you've got to get the information into it. So if you can connect up via these boards, all of a sudden you also have access to a whole world of process instrumentation as well. So just for example here, we've got 4 to 20 milliamp inputs and outputs, which covers the majority of process instrumentation out there. We've got thermocouples and RTDs, which probably covers the rest. And this is only for the major process instrumentation. If someone anywhere in the world has been able to think of an application, there's probably a board out there somewhere now that will cater for it. Additionally, with these units, and what makes them exceptionally powerful as well, is that a lot of environments now, whether it be electrical or process, are based on Ethernet. Now, in the past, I've had situations where I would have loved to have known what was going on the network at a given point in time. So if we've got a server or an IED, we've got an error file, we've got an alarm list which we can go back and interrogate. We can go back and maybe check what the last 15 seconds of analog waveforms were. But what goes on most networks, once it's passed from one machine to another, it's gone, and you're just guessing what was on there. So one application I really like for these is with the onboard Ethernet port, you can configure a log so that you can see everything, for instance, for the last 24 hours. About 8 years ago now, we had a network event. On a gas turbine, we had a control system configuration whereby we had this, let me just get a pen so I can write. We had a safety system, which ensures the safe operation of the machine. If any operational parameters go out of line, then it will trip the machine immediately. That safety processor did rely on some information from a non-safe processor, and that information was transmitted over the Ethernet. Now, this particular power station was made up of 3 blocks, each block containing 2 GTs. And each of the Ethernets on this block should have been fully isolated, except for a bus connection, which was used for the global DCS connection. But anything that happened on the Ethernet within this block should not have been able to propagate onto this block. However, on one particular day, we tripped both machines in this block, and instantly that's 800 megawatts out of the grid. We also tripped 1 GT in a steam turbine over on this second block, which I think in total, by the time all the trips were out, we'd lost 1.3 gigawatts on the grid. The whole grid came close to collapsing that day. Now, the scary thing is, because we had no idea what happened on that network, we never actually worked out what the problem was. It's never repeated, but it could happen tomorrow, it could happen next week. And tomorrow or next week, this could bring down the power grid in a whole country. Just because we don't know what happened on that network. We tried to recreate it as many ways as we could. The vendor themselves was very interested in trying to work out what the problem was, but neither they nor us could ever work out what it was. But if we'd had one of these boards on there logging through the commissioning period, there's a good chance we could have been able to go back and see what actually happened and prevent it from happening again. The power of the Ethernet port doesn't even stop there. I assume a lot of you are probably familiar with electrical protection. It's also possible with software to actually inspect what is going on over the network. So apart from actually logging, we can turn these computers into proactive devices as well. So for instance, if I had a spurious trip coming through, maybe I'm getting a goose message from a particular point, which is tripping half a dozen breakers, I could actually configure one of these computers to perform diagnostics at a particular point in time, or even email that information to me at the time it happens. once you get a computer like this, which is fully configurable, the applications are endless. Now, I mentioned before as well, it doesn't really end with electrical engineering either. So, for instance, civil engineering. One of the monitoring points, particularly in my line of work, which civil engineers often have to concern themselves with, is we've often got quite big, heavy foundations. And a lot of the countries I've worked in are quite warm, humid environments. So overheating of the slabs during curing is a major concern. However, if you can actually see the temperature within the slab, if you can embed some thermocouples, some RTDs, and actually see what the temperature is on an ongoing basis, you can cater, say, coolant as appropriate to ensure that the slab properly cures. Or it provides you with the QA information to say that it has properly cured. You could sense structural deformation with these devices as well. I can't remember what they're actually called, but you can get piezometers, which you essentially glue onto structures. And that will provide a signal to an analog input, which can be interfaced directly to the pies. In mechanical, for instance, the number of problems that I've encountered where the addition of an additional temperature sensor or pressure sensor could mean the difference between knowing what's happening or guessing what's happening. I would need a lot of hands, fingers and toes to actually count them all. And this sort of equipment can allow you to cheaply provide that sort of interface. I'd also point out as well that even interfacing video, these units are perfectly capable of acting as a video interface. So for the cost of, say, a $30 or $40 pie, another $40 for a camera, and if you've got an internet connection, you can see exactly what that pie is seeing. You can even get infrared cameras for them. And that's my evangelizing, if anyone's got any questions.
Are there any follow-on questions for Ben? Well, I think you've sold me with your evangelization of the small circuit boards, Ben. I'm keen. It's one of those things where I think it could be dangerous where you start small and then you'll end up with it'll become your full-time hobby. What do you think?
Yeah, you don't want to know how many of these things I have in the cupboard. See, the thing is, it's not as though these capabilities haven't been available before. The difference is that previously, like 15, 20 years ago, you would have to be looking at thousands of dollars to implement this sort of intelligence and sensing ability. Now, you're looking at hundreds of dollars.
It's unreal.
Well, the other way of looking at that, Ben, is that I'm thinking probably 30 years ago or something like that, when the first microcomputers came out on the board. I'm thinking of Signetics 2650. I bought one. We mucked around. We programmed it in machine language, and well, it was an assembler, and we were amazed by the sort of things we could do with the input-output ports and taking data off sensors and the like. What the difference is now is not just that there's more memory and more capability there, but your software, your developmental software, you've got this connected up with MATLAB. I'm impressed by that. You can the difference is enormous in the development capability. That's where I see it.
Yeah, it's all a lot easier now. It's a bit of a double-edged sword though, Mel. I think people like yourselves who learned in those early days in the base machine language assembly, you had to think about the problem far more there. I see a lot in programmers now, at least in the industrial environment, that this abundance of resources, the ease of which we can do everything, has made us a little bit lazy. So I've had a developer for quite a reputable contractor once tell me, oh, we can't do that. We've only got an 8-bit processor and we really need 16-bit accuracy. And he seemed to have forgotten that back in the days when we only had 4-bit processor, there's nothing to stop you from doing 16-bit maths with a 4-bit processor. It just takes a lot more operations. But he saw that as a complete roadblock.
Yep. Very good. Thank you. Thank you. Been most interesting. Thank you.
Just want to reiterate that. Thanks.
I have to sign out.
No problem, Mel. Thanks for attending.
Great stories.
And thanks very much, Ben, for your fascinating talk. I think we all learned a bit from it, and I really appreciate you volunteering for Backyard Inventions. And anyone else wants to volunteer, we've got Ron next week. I'll send out a flyer for soon. Please feel free to throw your name in the ring, and I'd love to showcase your invention. So thanks again, Ben, and thanks everyone for attending.
Great. Thanks, everyone.
Yeah, thanks very much, Ben.
Great stuff,
Thoroughly
Ben.
enjoyed
Thanks
it.
so much.
So Ben, you didn't put your email ID.
Yeah, I'm very sorry. One sec.
Or your phone number, whatever it is. Okay.
I'm just going to bring it up.
We have a makerspace hub starting up at TAFE, supposedly in the not too distant future, and we need your skills, Ben. So we might have to get you to share some of your makerspace knowledge in that sense.
I'm sorry, what was that?
Sorry, I was talking while you're doing something. There's a makerspace area that's had some funding recently for the TAFE Queensland at the Bowley Trade Centre.
Okay.
And they are keen to implement stuff that you're doing in that sort of sense, you know. So may have to catch up with you at some stage and see if you're interested at all in that sort of a thing. Not that I'm in any process to make it happen, but they're trying to get it started. Yeah.
Right, has to start from the start again. Too far. Okay, that's my email address there and my phone number as well. So if anyone does want to contact me, I'd certainly be interested to go out and have a look at the makerspace. Just give me a bell and I'm happy to head out.
Great stuff. I've got your details now, and I'm glad you're in Townsville.
Great.
Yeah.
Thanks, guys. Good night.
Okay, good night.
Thanks
Thank you
very
so
much, Ben.
Thank you.
You're welcome, Kenny. Give me a bell.
Will do.
Well,